Okay, this is guided notes for area of a triangle night number 2. Um, all of the problems that we're going to do today, except for one, are going to come out of the book. So if you want to do them in your book, the 3 problems that we're going to do from the book, that's fine by me. Although you're going to have to do the 4th one as well. And I just want to walk through word problems, applied problems, slightly more challenging problems, problems where you have to draw your own picture. So let's do this quickly. Um, the Flatiron Building in New York is well known for its unusual shape. Okay, the building was designed to fit the triangular plot of land formed by 22nd Street, Broadway, and Fifth Avenue. There's a lovely picture in your book of this building. It's a real building. The diagram here shows the dimensions of the triangular foundation of the building. What is the area of the triangle? Okay, for a triangle, we need a base. Okay, and we need a height. And the height has to meet the base at a right angle, okay? This imaginary line that we're drawing, the height line, meets the base at a right angle and goes all the way to the vertex, okay? Those are the 2 criteria, from the vertex to the opposite side at a right angle. And so let's do the math. Area equals base times height divided by 2, because base times height would give us an equivalent parallelogram, like if we were to extend it like that and like that, right? Base times height would give us the equivalent parallelogram, but we only want the triangle. So that's what we're going to do. Now, these are horrendous numbers. I would not expect you to do, oh, we're doing the same thing we did before when I had to delete the video and start over. I would not expect you to do 197.6 times 79 divided by 2. I believe you can do it. We have learned multiplication. We have learned multi-digit multiplication. We are so good at multi-digit multiplication. But it's just not a great use of your time. Instead, we can just do 197.6. That's about 200 times 79. That's about 80. 200 times 80 is going to be 16,000. Okay? Right, which that's a little less than 16,000. But that would be for the parallelogram. So we divide by 2 to get the area of the triangle. And we've got 7805.2 square feet. Okay, so that's a decent size for a footprint of a building. Okay. And if you think about the size of your house, it's probably not 7805 square feet unless you have a really big house. Okay, so for the next problem, what I want to show you, this is on page 545, and it's one of the just example problems, is I want to show you this 2 ways. Oh, I want to show it to you with decimals, and I want to show it to you with fractions, okay? We're going to do it in 2 different colors, page 545. Okay, so if we do it with decimals, let's start with decimals. Well, the base is 4.5, and the height is 3.5. Do we see that? Do we see that? The height is 3.5 feet. Okay. So if we do the math, then we have to be just good at decimal math. Base times height divided by 2. Okay. So 4.5 times 3.5. And then we just have to do our long multiplication. Right? That depends on how much we like it. 5 times 5 is 25, carry the 2. 5 times 4 is 20, 22. Okay, don't forget to put that placeholder 0 there. 3 times 5 is 15, carry the 1. 3 times 4 is 12, 13. We add it up, it's going to go off the page, and we're going to get, don't forget we need 2 decimal places, 1, 2. 15, yep, see we went off the page. We're going to get 15.75, okay? 15.75. Okay? Now, let's set that aside and see what would happen if we did it. We'll just change the color, nice purple, to fractions. Now, 4.5 is 9 over 2. 3.5 is 7 over 2. And then we're going to divide that whole thing by 2. 9 times 7, well, that's 63, okay? 63. 2 times 2 is 4. Divided by 2 is the same as multiplying by a half, right? We knew that. So that's 63 over 8. Now we have to turn that into a mixed number because it's a geometry problem. We really have to do that. And now we have a little less than 7. Because 64 out of 8 would be 8. I'm sorry, a little less than 8. So we actually have 7 and 7/8. Okay? Now here, we haven't finished this one because we never divided it by 2, fun fact. Now we have to do 15.75 divided by 2. Now 15 divided by 2 is 7.5. 0.75 divided by 2 is 0.375. So that's also going to give us the same number. It's going to give us 7.875 square feet. But it might be a lot harder for us to do that one. So if we're not feeling amazing with the decimals, we should always feel welcome to turn it into fractions, and fractions are our friend. So that's a second problem from the book. A third problem from the book is a word problem. Alani is building a set of 4 shelves. So fortunately, we don't have to visualize them because that's shown to us. Each shelf will have 2 supports in the shape of a right isosceles triangle. So if you don't know what a right triangle is, we will talk about those on Friday in workshop. A right triangle contains 1 right angle, not 2. It's not possible. We're not going to talk too much about why that's not possible, but 1 right angle, okay? An isosceles triangle has 2 congruent sides, at least. So that's congruent to that, okay? So we're basically trying to build a shelf that has these supports. It looks like the back of that will go up against the wall. It looks like it's sort of like a view of like the back of it. Okay, so we have 8 of those triangles because we have 4 shelves. Each shelf has 2 supports. They are shaped like triangles. If you have certain kinds of shelves in your house, go look at them. You may see that you have shelves in your house with triangular supports. Each shelf is 14 inches deep. How many square inches of wood are you going to need to make it? So in theory, you could go out and buy wood and create yourself some nice right isosceles triangles, build these shelves very successfully, right? If you did that, how much would we have? Well, what are the base and height of each triangle? So the key with an isosceles triangle is that both the base and the height are, pause the video and think of this, because it's isosceles, because it's the same, they're both 14 inches, right? And base times height divided by 2 is our formula. So we could do 14 times 14 divided by 2, and that's going to give us 1 triangle, okay? Now, this may blow your mind, but I don't actually have to divide by 2 because that number 196 square inches, that's actually going to give me 2 triangles. Now, they happen to not be scooched up against each other like a parallelogram. But if we wanted to do 196 divided by 2, we would need to multiply by 8 because we need 8 triangles. But if we said, hey, 196 square inches of wood will give me 2 triangles, will give me enough for 1 shelf, then I just need to do 196 square inches times 4. That's going to be a little less than 800. And again, you could easily do this without a calculator if you needed to. And that's going to be 784 square inches of wood. Okay? And in life, sometimes we do build things, and we need to know how much stuff we're going to need. So that's where this math can come in handy. The last thing we're going to do is draw the picture for this. This is going to be on the spicy side tomorrow. That's Tuesday. When you've got a word problem and you've got to figure out what does the picture look like, okay? That's something that you may have to do at some point on a future assignment. So let's take a look at that. 2 ropes extend from the top of a flagpole. Oh, flagpole, I know what those look like. To the ground, 18 feet away from the flag. Let's imagine that that's straight. From the flagpole's base on either side. Oh, okay, a flagpole. It's got ropes, that hit the ground. Okay. And we're assuming, by the way, that the angles are the same. We're not going to talk about why, but the angles are the same. I just drew that delightfully. Okay, the flagpole is 30 feet high. That's our base. Sorry, that's our height. Now, 18 feet on each side is going to give us information that we need about our base, okay? Now, the ropes each create a right triangle with the flagpole, right? Which only works if the flagpole is straight. Then we're creating a right triangle here, right, on each side. And each right triangle is half of a larger triangle with the flagpole at its center, okay? So to find the area of the giant triangle, we could do it in 2 pieces and glue it together, but why would we? We just need area, area, let's move it a little, area equals base times height divided by 2. The base is 36. How did you get the number 36? Well, it's 18 here and it's 18 here times 30, all divided by 2, right? And 36 times 30 is 36 times 3 is 108, right? 30 times 3 is 90. 6 times 3 is 18. 90 plus 18 is 108. But there's a 0 there, so we add a 0. So it's actually 1080 divided by 2. 1080 divided by 2. And that's going to be 540 square feet, right? Because this is a high, then that's a reasonable number for us because that's a very high flagpole. Okay, so those are some of the things you're going to have to do today. Good luck with